Welcome to The Explainer. Today, we're jumping straight into a totally fascinating journey regarding the geometry of reality itself. We're going to pull back the curtain on a secret code, a mathematical blueprint that is quietly dictating the shape of the world around us. And honestly, once you see it, you will never look at the world the exact same way again.
Think about this for a second. What do a lightning bolt, a modern smartphone, and a head of Romanesco broccoli all have in common? On the surface, absolutely nothing, right? One is a raw, explosive force of nature, one is a pinnacle of human engineering, and the other, well, it's a highly structured vegetable. But here is the wild part. They all rely on the exact same hidden geometric blueprint. It sounds a bit like science fiction, I know, but we're going to crack this mystery wide open together.
Section 1. The Hidden Geometry, Uncovering the Blueprint of the Universe. Okay, so to understand this blueprint, we really need to wrap our heads around a concept called self-similarity. Basically, this is a characteristic of a shape where its detailed structure repeats at arbitrarily small scales. So if you zoom in on a piece of the shape, it literally looks like a tiny, reduced-size copy of the whole entire thing. Back in 1975, a brilliant mathematician named Benoit Mandelbrot actually coined a term for this infinite, unfolding symmetry. He called it a fractal. And fractals are crazy because they completely defy our traditional 1D or 2D dimensions. Their detail is just infinite. You can keep zooming in forever, and the exact same patterns just keep emerging. Section 2. Math meets nature. Bridging equations and physical reality. So what is the actual difference between pure math and reality? Well, idealized math fractals, like the famous Cox snowflake you might have seen, they're built from exact perfect copies that repeat infinitely. But, nature doesn't really work in perfect, pristine equations. Natural fractals are formed by random natural events, so because of that, they aren't exact perfect copies. Instead, they are what we call statistically self-similar. Plus, they have finite scale ranges. That just means you can't actually zoom in forever because eventually you're going to hit the atomic level and the pattern stops.
And this perfectly illustrates exactly why Mandelbrot had to invent fractal geometry in the first place. He famously said it is meaningless to talk about the length of a coastline. Some other means of quantifying coastlines are needed. Which sounds totally bananas, right? How on earth can it be meaningless to measure a coastline? Well, this is known as the coastline paradox. Mandelbrot realized that if you measure the coast of Britain with a giant yardstick, you get one specific length. But if you swap that out and measure it with a little 1-foot ruler, suddenly you can trace all those tiny jagged little curves that the big yardstick missed, and your measured length actually increases. So if your ruler just keeps getting smaller and smaller, the coastline mathematically gets longer and longer, straight towards infinity. Traditional tape measure math just completely fails us when we try to measure these jagged, self-similar borders found in nature. But once you know what to look for, you start to realize nature has this massive hidden fractal playbook. I mean, we see this self-similar branching in massive river networks carving their way through entire continents. We see it in the jagged, branching flash of lightning bolts tearing across the sky. We see it in the perfect, spiraling cones of Romanesco broccoli at the grocery store. We even see it all the way down at the microscopic level, in the actin cytoskeleton of our own cells, and in the delicate crystalline growth of snowflakes. This secret blueprint isn't just common, it is absolutely ubiquitous. It's everywhere. Section 3. Designing modern technology, hacking the fractal blueprint. Now, human engineers, they've essentially become fractal hackers. Here's the deal. In wireless communication, the length of an antenna generally needs to match a specific fraction of the wavelength of the frequency it's receiving, usually about half the wavelength. But what do you do when you need to fit that antenna inside a tiny, paper-thin device? You use fractal geometry. By folding an antenna into self-similar shapes, like a Sierpinski gasket, which is this really cool repeating triangle pattern, engineers can pack a massive amount of electrical length into an incredibly tiny, compact physical space. It's a total game changer. And hey, this isn't just some theoretical lab experiment. This is literally the tech sitting in your pocket right now. Your smartphone, your laptop, those little USB dongles, they all rely heavily on fractal antennas. And because these fractal antennas are self-similar at different scales, they can actually pick up multiple different frequency bands simultaneously, all from within that exact same compact space. We're even taking it a step further and using fractal structures to build low-resistance power transistors on modern microchips. By mimicking the exact way nature efficiently distributes resources, like, say, a river delta spreading out, we are completely revolutionizing modern electronics.
Section 4. The Fractal Brain. Why our minds crave complex geometry.
Okay, here's where things get super introspective. Neuroscience has discovered this wildly fascinating concept called fractal fluency. Think about it. Over millions of years of human evolution, gazing out at these fractal-rich environments like forests, rolling savannas, and dramatic clouds, our human visual systems actually adapted to process these specific natural patterns with incredible efficiency. When our eyes track a fractal pattern, it literally induces a physiological comfort zone. Our brains are hardwired to crave this geometry. When we see it, our physiological stress actively drops and our cognitive abilities get a massive boost. And the research gets even more remarkably specific than that. Listen to this number range, 1.3 to 1.5. In mathematics, fractals are assigned what's called a d-value to measure their visual complexity. So a d-value near 1 is going to be very sparse and smooth, while a d-value near 2 is incredibly dense and intricately detailed. Well, neuroscience experiments using continuous EEG monitoring have dramatically revealed that this specific mid-range, 1.3 to 1.5, is the absolute sweet spot. This is the exact fractal dimension of natural scenery that our visual systems process totally effortlessly to trigger a state of profound calm. And this preference is so deeply ingrained in us that it even shows up in our art. Take the famous painter Jackson Pollock, for example. His chaotic, dripped paint canvases might just look totally random to some people, but scientists actually analyzed them and found that they share the exact same mid-range fractal dimension as natural scenery. His fractal expressionism actually induces the exact same positive, stress-reducing physiological responses in our brains as staring out at a peaceful forest or a jagged coastline. Without even knowing the math, he was intuitively painting the hidden blueprint of nature.
Section 5. Building Better Spaces, Biophilic Design and Architecture.
Now, here's a statistic that is quite frankly staggering. Modern humans spend roughly 92% of their time indoors, completely shut away from nature's scenery. 92%! We have effectively removed ourselves from the very geometry our brains evolved to need. We're literally starving our minds of the stress-reducing fractal fluency of the natural world, locking ourselves away in environments filled with harsh, straight lines and sterile, non-fractal boxes. But the good news? Architects are fighting back, and they're using something called biophilic design. A really prominent example of this is the Fractal Chapel at the University Hospital in Graz, Austria. The designers there are literally building mid-range, natural fractal patterns directly into the architecture, the lighting, and the spatial layouts of the hospital itself. By purposefully integrating this specific geometry into our built environments, they are successfully lowering human stress, improving overall well-being, and actually aiding patient recovery times. I mean, we are literally using math to heal people. How cool is that?
So we started off talking about a lightning bolt, a smartphone, and a piece of broccoli, uncovering that self-similar thread that ties them and us all together. But it leaves us with one final, kind of mind-bending thought. If our technology, our architecture, and even the subconscious comfort of our own minds are quietly being shaped by fractal geometry, what other hidden math is out there, quietly dictating your life right now? Thanks so much for exploring with me today. Keep looking closely at the world around you.